In RT3 Lesson 2 Part 1, by the end of the lesson, you will be able to solve problems involving the angle of depression and the angle of elevation. So today is all about real-world application problems. Before we get into new material, let's remember the acronym Sohcahtoa, and it is there to help us remember our trigonometric ratios. So let's remember So stands for sine of an angle equals opposite, so the opposite side length over the hypotenuse. Ca for cosine equals adjacent over the hypotenuse. And finally, we have toa, which helps us remember that tangent is equal to the opposite over the adjacent. First, we have the angle of depression. And this starts at the horizontal. So let's say we have this horizontal, and it goes down. So it goes down here, and it creates the angle of depression. X here would then represent the angle of depression. You can think about when somebody is depressed or has a depressed mood, they are feeling down. We have the angle of elevation, which again starts at the horizontal, but this time it goes up. So this right here would be considered, X would be considered our angle of elevation. Let's take a look at this picture, and we're going to label the angle of elevation and the angle of depression. So let's first look and notice we have this horizontal, and the amount that our head would have to look up, okay, to see that airplane, that would be the angle of elevation. The amount that our head would have to look down, or our eyes would have to look down at the boat, would describe the angle of depression. Again, all stemming from that horizontal line. Let's just take a moment and let's imagine we had another line here, and that line, right, was horizontal, so it was parallel to this line up here. And we wanted to figure out, let's say, this distance here. We could use the fact that we know alternate interior angles are going to be congruent. So this would also be why. These two angles would be congruent because we have parallel lines and are transversal. Let's take a look at an example. The angle of depression from a boat to its anchor measures 50 degrees. We're given that here. If the anchor chain is extended about 200 meters, how deep is the ocean? So they've labeled, this is 200 meters. What we are trying to find now is X. How deep is it? For now, we are going to imagine that the ocean is perfectly flat and the bottom of the ocean is also perfectly flat, creating those two parallel lines. So we have alternate interior angles. We will know that this angle here will also be 50 degrees. Let's stop here for a moment and remember Sohcahtoa. As I'm looking, I see I have an angle measure and I have two side lengths. I have the opposite and the hypotenuse. As I look at Sohcahtoa, I remember, and I can see OH is for sine. So we're going to use sine of 50 gives us our opposite, which is X, over our hypotenuse, which is 200. We now need to solve for X. I'm going to multiply both sides by 200. So I have 200 times sine of 50 equals X. I'm going to put this in my calculator. Again, make sure you check that your calculator is on degrees. When you do that, you get X equals 153.2, rounding to the nearest tenth, meters deep. Now I just want to pause here for a second and go back to our picture. You could have actually solved this a different way, realizing that this angle here would be 40 degrees because we have a right angle. 40 plus 50 gives us 90. And you could have used cosine. You would have gotten the same exact answer. Let's take a look at example number 2. The angle of elevation from a sailboat to the top of a 121-foot tall lighthouse measures 16 degrees. To the nearest foot, how far is the boat from the lighthouse? So if we look at our picture, we're going from the sailboat to the lighthouse, and we can create our triangle. It says that the angle of elevation, remember we start at the horizontal and we're going up, so that makes this angle 16 degrees. The lighthouse is 121 feet. Remember, this triangle is a right triangle, and we're trying to find this distance x. We got to remember Sohcahtoa. And look at what we're given. So we have an angle measure. We have the opposite over the adjacent. So as I look at Sohcahtoa, opposite and adjacent, we're going to be using tangent. So tangent of our angle, and we know our angle, so we can write it in, tangent of 16 equals opposite, which is 121, over our adjacent, which is x. Now we need to solve for x, so first we need to clear our fractions. Multiply by x on both sides. We get x times tangent of 16 equals 121. Now to get x all by itself, we're going to divide both sides by tangent to get x equals 121 divided by tangent of 16. Remember, showing your work is really important. Don't try to do it all on your calculator. At this point, we can put this into our calculator. 121 divided by tangent of 16. In your calculator, you get x equals 422 feet. Example number 3 says to find theta. Remember, theta is just another variable here. It's describing an angle measure. So as we look at our box, we want to find that theta. But the first thing that I'm going to find is this measurement here. And since we have a rectangular prism, we know that this length is 16. And I know that this at the bottom is a right triangle. We have a right triangle, which is going to help us by using Pythagorean's theorem to find the missing side length. So 16 squared plus 30 squared is going to give us, we'll call that x for now, x squared. 16 squared is 256. 30 squared is 900. I can add those together, and I get 1,156. Take the square root. I get x equals 34. So I know that this length here is 34. Now I'm going to look at the triangle that's kind of inside our box right here. And we know that if this length is 20, this length here is also 20. So as I look at this, I now have enough information. We're going to remember Sohcahtoa. And I have my angle. That's what we're trying to solve for, so we don't know that. I have the adjacent and the opposite. So as I look at Sohcahtoa, I'm looking for adjacent and opposite. Toa uses opposite and adjacent, so we're going to use tangent again here. So tangent of theta, theta is going to be our variable here, equals opposite, which is 20, over adjacent, which is 34. Now remember, in our last lesson, we learned when we're trying to find that missing angle measure, we need to use the inverse. The inverse here is inverse tan. So I'm going to multiply both sides by tan inverse. On the left, the tans cancel, and I have theta. On the right, I am finding tan inverse 20 divided by 34. Remember, in your calculator, you're going to use that tan inverse button, tan to the -1. It's second tan, and you're going to substitute this into the calculator, and it is going to give you our theta, or our angle measure. When we do that, we get theta to equal 30 degrees. Go ahead, check out this YouTube for more help. Now it's time to practice.